Hey everyone, welcome back to our C programming series. Today we are diving into one of the most powerful yet often misunderstood topics in C, which are pointers. Understanding pointers can open up a whole new level of control and flexibility in programming. So let's break it down in a simple way. So, what exactly is a pointer? In simple terms, a pointer is a variable that holds the memory address of another variable. Normally, variables in C store data like integers, floats, or characters. But a pointer doesn't store the actual data. It stores the address of where the data lives in memory. So, if you look at the diagram, let's say we have an integer variable called var. So, we usually define this in this way: int var is equal to 10. Now, when we define a variable var equal to 10, what we are actually doing is we are basically assigning a storage in memory at some particular location called as the address. Okay, so at a particular address, we are assigning some storage and we are giving that a name called as var and also a value of 10. Now, this location, also known as address, is represented as a hexadecimal number. So it can be any hexadecimal number in memory which the basically the program after execution assigns. Now we do not know that the actual location. And if we want to access the actual location or find the location of where the data is actually located in memory, we can use pointers. Now, in this case, what does a pointer do? It stores the address of another variable. So, when I declare a pointer variable, what does a pointer variable do actually is it will store the address of where this variable var is located in my memory. Okay, so when we declare a pointer, we can make it point to memory address instead of holding an integer value in this case. Think of it as a way of telling C where we can find the variable var in my memory, that is here at this memory address or location. Okay. Now let us have a look at the syntax of a pointer. In C programming, we declare a pointer by specifying the data type it will point to, followed by an asterisk, and then we have the name of the pointer. So let's say we want a pointer to an integer variable. We will write it in the following way: int asterisk ptr. Now here what I have done is I have defined an integer pointer, that is a pointer to an integer type. Now we have just defined a pointer, but we haven't given it a value, that is an address which it will point to. Therefore, to assign memory address to a pointer, we will use the address of operator, that is the AND operator. For instance, in the previous example, if var is an integer variable, okay, then if we want to assign the address of var to the pointer ptr, we would do it in this way: ptr is equal to and var. So what would this do basically? It would give me the address of the variable var in memory, and this address will be assigned to this pointer variable. Now this pointer points to var's location in memory. Now let's say we want to access or modify the value that a pointer points to. Okay, that is the value of var. So how can we access the value of var by using the pointer? Very simple. We will use the dereference operator, which is simply the asterisk which we saw, which we will see how to use. So for example, if this pointer points to the variable var, then using the dereference operator, that is dereference operator followed by the name of the pointer, will give us access to var's value. That is, this would give me the value 10. This is called as dereferencing the pointer. Now let us put this all together in an example. So I'll open my Visual Studio Code. I will create a new file. Okay, so let's go ahead and understand how pointers work. So first what I'll do is I will declare a variable var and give it the value 10. Okay. Or we'll take a number and give it a variable called num and give it the value 10. And now what I will do is I will declare a pointer to this variable. Okay. So int asterisk ptr, and we will store the address of this variable num. Now what I am doing here is the address of this variable num is being stored inside this pointer variable. So let us go ahead and see what are the address of this particular variable. So first what I will do is I will just print the value of num. Then what I will do is I will print the address of num. Okay, we will use the address of operator for this. Address of num. Now the address of num I can get it by using the address of operator. Remember we use %p to as the format specifier to print the address. This will be a hexadecimal value. Okay, and num. Now let us print the address of the variable num by using the pointer, which is the value of the pointer, that is address of num. This too will give me the same address as in the above printf statement. And now let us print the value of num, okay, by using the dereference operator. Value at address stored in the pointer is %d-n, since this is an integer value, and we will use the dereference operator to print the value, and we will return 0 after the program executes successfully. Let's go ahead and compile it. Let's run this program. So in this example, you can see that we declared a number with the value 10 and a pointer to that number. Okay. So as you can see here, the value of number is 10. The address of num is this hexadecimal value which we got here. Similarly, we print the address from the pointer variable, and using the dereference operator, we print the value stored at that address. Okay. So this is how we can use pointers in C. Now let us have a look at how we can use pointers in functions. Okay. So when it comes to functions, there are two ways of passing arguments to a function, that is call by value and call by reference. Now this is one of the most important topics to understand in C programming, since this will help you in performing dynamic programming. So first let us understand what is call by value. Now when we pass variables by value to a function, what we actually do is we pass copies of the actual values. Okay, this means that any change made to the parameters inside a function won't affect the original values. Let's see this with the help of another example. So let's say I will make a function. Okay, I will define a function that will modify the value of a variable. So let's go ahead and see that. Void modify, and I will give it, I'll pass the value x. Okay, now x equal to x plus 5. This will increment the value of x by 5, and here I will inside modify function, okay, the value of x will be %d, and I will print x here. Okay, and the variable which we want to modify, we will pass it from the main function onto the modify function. So int a is equal to 10. Now we want to modify the value of a, that is 10. Okay, therefore before calling modify, we will print the value a equal to %d, and we print the value of a before modification. Then we will call the modify function, and then what we will do is we will print the value of a again after modifying it. Now in this case, what will happen is if we run this program, you can see that Before calling modify, the value of a was 10. Inside the function, the value incremented, but that is the value of the local variable x. That is the value of a which we pass to this function. But after calling modify, the value of a still remains the same. Okay, so what happens here is the function only modifies a copy of a. So a in the main function remains unaffected, and when we print a after the function call, the value of a is still 10. Now what if we don't want this? What if we want to actually change the value of a? So how can we do that? In order to do this, we will pass a pointer to the function, that is a pointer to the modify function. Okay, that is the address of a. So by passing the address of a, what will happen is I will change the actual value at the memory location where a is located. So let me explain this in the following diagram. So what I'm doing here is I'm declaring a variable a which is in my memory at a particular location, and a has the value 10. Now when I pass this value a to a function, the function's local variable which is x has its own memory location. Now this here will increment the value of a, that is a copy of a, by 5, which will give me the value 15. But in this case, what is happening here? The value of x is changing, not the value of a. So a will remain as it is. If we want to actually change the value of a, I will have to pass the memory location, that is the address of a, which will make changes to the value which is located at this address. Then only a will become 15. So using pointers I can achieve this, and this is known as call by reference. So let us see what is call by reference. So in call by reference, we use pointers to pass the memory address of variables we want to modify. Okay, that is, we pass the address. This allows functions to directly modify the original values. Therefore, instead of passing the variable itself, what we will do here is we'll pass pointer to that variable. So let's go ahead and just modify this program a bit and see how we can change the actual value of a. So what I will do here is, rather than declaring the passing a as a value as a copy, I will pass the address of a. So for that I will have to declare a pointer here as my parameter. Okay, I will use a pointer parameter. Then what I will do here is I will use the dereference operator, that is, it will dereference the address x, that is the address of variable a, and what I will do here, I will take the value, that is, this will give me the value 10, and I will add 5 to it. So this will actually change the value which is located at the address of a. So one more change we have to make here is, here I have to make sure I am passing the address of a. So I will use the address of operator, okay, the AND operator. So let's go ahead and compile this and run it and see what do we get. Just a small mistake. Expected insta, but argument is of type int. Okay. So what mistake have we made here? Yeah, the printf statement. One thing we have to make a change here and modify int star x int a, modify val and a. I pass the value of the address. Okay, let's go ahead and compile it. And now we'll run it. Okay, so as you can see, before calling modify, the value of a was 10. Inside modify, the value was 15. And after calling modify also, the value of a became 15. So in this case, we pass the address of a to the modify function, and the function now operates directly on a in memory. So any changes it makes are reflected outside the function also. Therefore, after printing the value of a, we get 15 as the incremented value of a. So what happened here is we actually changed the value of a which was located at that location in the memory. Okay. Now let's take another example. One of the most famous examples where pointers are used is in swapping of two numbers. So when swapping two numbers, using call by value won't work because each variable's value is only modified within the scope of the function where the modification takes place. However, if we use call by reference by passing pointers, we can swap two numbers in the calling function itself. And here's how we will write the code for this. So first I will make my swap function, void swap, and inside this function I will pass the address of the two variables I want to swap. Okay, let's say I want to swap the variables a and b. And here what I will do is I will store the value of a by using the dereference operator inside a temporary variable. Then by again using the dereference operator, I will store the value of b into a, and similarly I will store the value of a into b. So this is how, using pointers, I can swap two variables. Now let's have a look at this. We will call this in the main function. Let's take x equal to 5 and y equal to 10. Now I want to swap 5 by 10 and 10 by 5. So I will print here, before swapping, x is equal to %d and y is equal to %d, the value of x and y. And I will now call the function, the swap function, and remember we have to pass the address of x and y for them to be swapped properly. Okay, if I do not pass the address, my compiler will give me an error. And now we will print the value of x and y after swapping. So let's go ahead, compile and run this program. So as you can see here, before swapping, the value of x was 5 and the value of y was 10. And after swapping, the value of x is 10 and the value of y is 5. Okay, so just to summarize this, here the swap function receives a pointer to x and y. Okay, allowing it to directly access and swap their values. And after calling swap, the value of x and y in the main function have been interchanged. Okay, and this is a great example of how pointers enable us to modify variables across different functions. And that's an introduction to pointers and the concepts of call by value and call by reference in C. Now, understanding pointers can feel tricky, but once you get the hang of it, it opens up a lot of possibilities for dynamic programming in C. So thanks for watching. Be sure to like and subscribe if you found this video helpful. In the next video, we'll go even deeper into pointers. Okay, so see you then and goodbye.